So whenever our warm-up is a math talk, you are trying to do the problem without scratch work, without a calculator, and you are putting your thumb up when you think you know the answer. So for this set, you are deciding whether each statement is true or false. Put your thumb up when you think you know for the first one, if it's true or false. So 3 is the only solution to x squared minus 9 equals 0. 3 is the only solution to x squared minus 9 equals 0. Put your thumb up when you know whether that is true or false. Okay, Michaela, what do you think? True. All right, so solutions mean like values for variables that make the statement true. So 3 squared plus, or 3 squared minus 9, does that equal 0? Yeah, because 3 squared is 9 minus 9, that does equal 0. So 3 is a solution. Is it the only solution? Jack? Like 0 squared minus 9 equals 0? That one doesn't work. But can anyone think of another number that can make it work? Positive 9 makes it work. So 9 squared minus 9 equals 0. Anyone else? You all thought this was true? So this one is actually false. There is another number that makes it true. If it's hard for you to tell, like, because I think right now what people were doing was a guess and check for the other number that it could be. Here's maybe how you can solve it for sure, which is to isolate the variable. Always start with what's farther, so that would be the 9. How would I cancel a minus 9? Add 9, whatever you go on one side of the equal sign, use in the other. So I get x squared equals 0 plus 9 is 9. Opposite of squaring something is square rooting. And last week we learned that anytime we square root moving forward, you need to write both the positive and negative case. It can be positive 3 and negative 3. So false can also be x equals negative 3. Right, but they're meant to be tricky, so I mean, no, and no one really said it. Maybe they thought it, but they didn't say it. What else about that? Oh, if you are using a calculator and you're trying out in your calculator -3 squared, or like a negative number squared, and it tells you that it equals a negative number, it's because you forgot to put parentheses around the number that you're plugging in. The calculator will read it wrong if you leave that out. So know that whenever you square something, it should always equal a positive. Questions on that? So then here's the next one. Put your thumb up when you think you know whether it is true or false. A solution to x squared plus 25 equals 0 is -5. Thumb up when you think you know whether that's true or false. Headphones and lights. Looking for those stuff. If it's true or false, if they come up anything. Okay, Harley, what do you think? False. So let's see. A solution means value for the variable that makes it true, so if we're trying to see if this is a solution, I'm gonna plug it in for the variable and see if it makes the statement true. What's -5 squared? And then is 25 plus 25 0? So then that is why this is false, this is false. Not a solution to that equation. Now make it sure. Here's the next one. X times the difference of x and 7 equals 0 has two solutions. Put your thumb up when you know whether it's true or false.
X times x minus 7, true or false?
Excuse the interruption. Teacher.
Unit. 50-50 chance. Is it true or is it false? Okay, Andre, what do you think? Do you know what the two solutions are? And that is correct. So one, is this quadratic? X times x minus 7, would it produce a U shape if I graphed it? What's the minimum requirement for something to be considered quadratic? An x squared, and although you might not see the x squared like you see it in these two, if I were to distribute, I'd get x squared minus 7x, so it is a quadratic. And most of the time, quadratics have how many solutions? Two, not all the time, but most of the time. So if you had to assume, we could go based off of that. But also, last week we learned how to solve these. If it multiplies to give me 0, then that means one of the numbers must be 0. And this is what I have here. I have two factors. X and x minus 7 are being multiplied together. We learned that if we set each factor equal to 0, we can solve them separately for like what this parentheses has to be to make it 0, or this one. So the first one's not a parentheses, but when I set it equal to 0, that is one of my solutions. And then when I go ahead and do some algebra on this side and solve, my other solution is that. So yeah, two solutions for that one. Last one for the warm up. 5 and 7 are the solutions to x minus 5 times x plus 7 equals 12, which is almost anything you know. Yes. True or false, are these the solutions? I'm not sure. What do you think the solution should be? Okay. Anyone else want to chime in? Anyone think they know what the solution should be? Michaela? Okay. Now, how did you guys confirm? Did anyone do any like graphing? So I think at this level, because I need to teach you all the methods of how to solve quadratics without graphing, but we haven't done all of them yet. We're like slowly walking you through them. The only way that I'd be able to easily identify the solutions to this would be if it equals 0. And right now it equals 12. There's lots of numbers that multiply to get 12, like 12 times 1, 6 times 2, 3 times 4, and I'm sure you could even like mess around and make some of those decimals somehow. But I can't like assume that this has to equal 12 and this has to equal 1 and vice versa. You can't do that. It only works if it's equal to 0, because we know if it multiplies to give 0, one of them must be 0. And that's not working for this one. So even when I read it initially, and when another student said the answer and I went to check, I did at first think that solution should be 5 and -7, but that only works if it's equal to 0, which is not. So the only way I would think you could solve this one at this level of your knowledge is to graph it. But either you listen to me that you might not have graphing and so you didn't even try, or you just didn't feel like it. I don't know, one of the two. I didn't really see anyone try it. But if I were to graph it, it would reveal my two solutions, like this. And it is not the two solutions that they said. Okay, so this is false. You could put that the solutions are approximately these numbers if you want, but at this level of your knowledge, I think you only be able to truly identify the solutions if you graph it. Question one. Okay, so that was a good warm up and covered a lot of key skills that we already know and stuff that we will know or will learn how to do, which is how to solve them, even if they look like that right now. The title of today's lesson is How Many Solutions? So our learning goal is to use graphs to investigate quadratic equations that have two solutions, one solution, or no solution. By the end of it, you should be able to explain why dividing a variable to solve a quadratic is not a good strategy. That is actually directly related to one of your constructive response questions. Also, you need to know that quadratic equations can have no solutions, and you need to be able to explain why there are none. So we're on lesson 5. How many solutions? I report every day in case you didn't know that by now. So definitely don't procrastinate in this unit. Stay caught up to the last unit. There's just no time for procrastinating anymore. Puzzle piece is lesson 5. And your next quiz will be this Friday, second half of class, over everything from unit 7 so far. So unit 7 is very similar to unit 6, covers a lot of the same concepts. If you are one of those people that are unhappy with their unit 6 score, consider coming to tutoring on Tuesdays with me, doing correction, maybe retaking it. There is Saturday Academy this Saturday, so if you are failing, you should expect to receive an invitation from me. There is still ways to pass, so definitely want to do that versus the alternative, which is retake the class. But moving on. So first activity is that you are going to solve these 3 equations by graphing. So you are allowed to use graphing technology. Be able to identify the solutions and maybe sketch the graph, because that will be important for you. If you get that pretty quick, doesn't mean it should be pretty quick if you're using graphing technology, then answer these next 2 questions. So why might it be helpful to rearrange each equation to equal 0 and then graph the non-zero side? And how many solutions do each of the 3 equations have? I'll give you 3 to 4 minutes to try that. 7, how many solutions does the first equation have? And what are they? And that is correct. That one I can tell even without graphing, because it's in factored form, it's equal to 0. I know that if it multiplies to give me 0, I basically need to figure out what value of x would make this parentheses 0. And what value of x would make that one 0. So yeah, so there's solutions for that one. I'm gonna write them like this, which you might see, so I just need to start getting you used to it, where it has like the fancy brace. and then a list of what the x's can be. So that's saying x can be 3 or 5. Table 8, what are the solutions for the second one? All right, anything else? Okay. Table 9, what are the solutions for the last one? Okay, so table 9, solution for the last one. Okay, saying a no solution, so let's see if that's right. But we'll see in a little bit. Let's try answering this. So why might it be helpful to rearrange each equation to equal 0 on one side? And then graph the expression on the non-zero side. So did anyone actually try that yet? Okay, then let's try it together. So for example, this first equation already is equal to 0, so that's an easy one to try. What it means is that when you're graphing it, you're graphing like just the side that is not 0. Okay, that's what it means by non-zero side. So see the difference if you put it with the equal sign equals 0 and without the equal 0 part. X minus 5, x minus 3. Right, here's what it looks like if I don't include the equal 0. Everyone see that? Make an observation what it looks like. Now look at when I put it equal 0. So what's the difference? Harley? Okay, without the equal 0, you could see the U shape, you could see it's quadratic, you could still see the solution. That they are 3 and 5 for that one. But when I have it equaling a number, I mean, it still gives me the right solution, but you can't see the U shape. So that's why it might be helpful to make the equation equal 0 and then graph the part that's not 0. So that you can write down as a sentence. So if I were to graph, say something like this, say graphing this expression is helpful because you can see the U shape. Versus the other way where you can only see the x-intercepts. When you can see the U shape, you can see the y-intercept, you can see the vertex, you can see every single input-output combination. But when you have it where it equals 0, then you can't see the two Ron. When on that. Okay, so graphing this with the equal 0, you can only see parallel lines where the x-intercepts are. But it still gives you some info. It's not everything you might possibly need. So then try that with the others. Set them equal to 0 if they're not. Now that doesn't mean just cross this out and put a 0 there, because then it'll have the same solution as this one. It has a different solution. So how can I make -1 become 0? I could add 1 to it, and then whatever I do on one side of the equal sign. So if I were to graph this, and you could write it like this, how I wrote it, or change the order, doesn't really matter. Then I should be able to see that my solution is 4, that's truly the solution. Let's see what that looks like. Adding 1 to that expression makes it equivalent to our second equation. And yes, it does just have one solution. And the solution is 4, so that is right. If you had done it where, and I don't know if they really did it either way, but it would still show you the right solution. But when you put it equal to 0 and graph the non-zero side, you see the U shape and everything. So this is what it looks like if it has just one solution, where the vertex is the x-intercept. That's why there's only one in that case. For the last equation, how can I make this one right here, how can I make this one equal to 0? How can I make the -4 become 0? I could add 4. And whatever I do on one side of the equal sign. And then if I graph the non-zero side, because that would make this side equal to 0. And you can write it this way or the other way. Now, if I type this in Desmos, I can see my solution for that. What I'm gonna do. So +4, because that's what we have to do to make it equal 0. Why does this one have no solution? It doesn't touch the x-axis at all. And we talked about how solutions, x-intercepts, zeros, roots, they all mean the same thing. So if solutions and x-intercepts, let me rephrase that. If solutions are x-intercepts and there's no x-intercept, then you have no solution. So there's that. Questions on that fact? Okay, so they were right in saying it's no solution. If you rearrange it where it's equal to 0 now, you can better see the usage. This last question is how many solutions do each of them have? I'm gonna write my answer underneath the equations. This one had 2 solutions. This one had 1 solution and only touched the x-axis 1 time. And this one had no solution. Those are your 3 possibilities. You can never have more than that. A fraction of that is 2, 1, or none. Any questions? So on the bottom part of your paper, you have a few like straightforward problems. Some of them you should know how to do already. Some of them might confuse you a little bit, but remember, you could always rearrange it, set it equal to 0, and then continue forward. So I'll give you maybe 3 minutes to try those problems at the bottom of your paper. There's also like 2 more on the back too. And then we'll go over them shortly. Like I might just project the answer because of time, but have them attempted first.
You pack up.
All right, but 1 and 2, I did not need to graph those to find the solution because it was pretty easy to isolate the x, like when it's in standard form and there's no x to the first power, pretty easy just to isolate x. So for 1 and 2, there's 2 solutions, plus or minus 11, plus or minus 6, and there's no response for that. For number 3, I also did not need to graph that one because it was equal to 0 in factor form. I just have to think what number needs to make each parenthesis 0. So 4 minus 4 would make that 0. And they're the same exact parentheses, so just one solution there. This one I still need to graph, but at this level, from what I've taught you, I think you should only solve 4 and 6 by graphing. Now, number 5, look at this one. Even if you're packing up, look at it. Why did 5 have no solution? But then, why did number 5 have no solution? I was thinking to figure it out. I tried isolating the x by getting rid of the squaring 2. Opposite would be square rooting. What's the square root of -4? -2 squared is 4. not -4. Not +2 either. If you try doing square root of -4 in your calculator, what does it say? So that means you can't do it. You can't take the square root of a negative, it's impossible. So that's why there's no solution. Good, any questions? Okay, well then that's.